Hello, this is Sadbir. This is our second video on how to calculate the limit of a function. In our previous video, we learned how to calculate the limit of a function using a table or using the graph of a function. In this video, we will discuss some algebraic method to calculate the limit of a function. So very first algebraic method is when you can just directly substitute the value of the limit into the function and get a number. For example, in our first problem, if I directly substitute, so if I plug x is equal to -2 into the function, I will get 2 -2 square minus 3 times -2 plus 4. And if I simplify this one, I will get 18. So this is a number. So my limit in this case is 18 for this function. Here is another example. So if I plug x is equal to 4 in the top and bottom, I will get in the top 16 plus 4 minus 2, and the bottom I get 4 minus 2. And by plugging these numbers, I get 18 divided by 2, which is 9. So this is my limit. So this is the direct substitution. So if you just plug the direct value of your input into the function, and if you get a number, then that is your limit. And now question is, can you calculate any limit by just directly plugging the x value into the function? The answer is no, because in some situation you can end up in a situation where you get 0 over 0 and 1 over 0 form. So if you get over 0 over 0 or 1 over 0 form, and that tells us that we need further simplification of the function to calculate the limit of those type of situation, because these are the indeterminate form, these are not a number. But yes, you can always directly plug into your limit into the function and calculate the limit if that limit end up being a number. So for example, in these two examples, if we try the direct plug-in method, it will not work. So suppose if I plug x is equal to 1 in the top, I will get 0, and 1 in the bottom, I will get a 0 over 0 form. So this is indeterminate form, and this will tell us that we need the further simplification of this function before we do the direct substitution. So let's see how to calculate the limit of such a function when you get 0 in the top and 0 in the bottom. So in this case, I have a polynomial function in the top and polynomial function in the bottom. So if you have a polynomial in the top and polynomial in the bottom, what we need to do is we need to factor the top and factor the bottom. If I factor the top, I will get x minus 1 and x plus 2, and the bottom is already factored, which is x minus 1, and you see there is going to be a cancellation. So if I cancel that one, I will get the limit x approaches to 1 of x plus 2, which is equal to 3. So if you have a 0 over 0 form, it will tell you that basically you have to factor the top and bottom. And as you can see, this was the factor x minus 1, which was making the 0 in the denominator. After the simplification, you will get that x minus 1 in the top as well, because this x minus 1 was making the 0 in the top and bottom, and you were getting the indeterminate form because of this x minus 1, which was hidden in this x square plus x minus 2. So you just have to get it out by factoring the polynomial in the top. Here is one more example where we will see that if I plug x is equal to 2 in the top and bottom, I will get both 0 over 0 form. Before I factor the top or bottom, first I have to FOIL the top, because uh, I would need to get the polynomial in the top and polynomial in the bottom so I can factor it. So if I FOIL the top, I'm going to get x square minus 8x plus 16 minus 4 and divide by x minus 2. Limit x approaches to 2. So since x minus 2 is making a 0, so there will be some hidden x minus 2 factor in the top, which we need to basically find out. So if I take the limit x approaches to 2 and simplify the top, which is basically x square minus 8x plus 12, and this is a x minus 2. So there will be hidden factor x minus 2 in the top, which if we factor that, you will see that x minus 2 in the top, x minus 6, these are the two factor, and x minus 2, sorry, that cancel out, and then you have limit x approaches to 2 of x minus 6, which is -4. So this is our limit. So this is the situations when you have a polynomial in the top and polynomial in the bottom, and if you plug the limit, if you try to do the direct substitution, you get a 0/0 form. This basically telling us to factor the top and factor the bottom. So you need to get a polynomial in the top, polynomial in the bottom, and once you factor it, the 0/0 form will cancel out. The factor which was making the 0 in the denominator or making the 0 in the top, it will cancel out. And once then you plug the limit, you will get a number. Here I have a practice problem for you to practice, which is a quiz problem number 1. Please pause the video for 1 and 2 minutes, and once you're ready, you can leave the answer in the link above. Here is another quiz problem number 2. Pause the video for 1 and 2 minutes and practice this problem. And once you have your answer, you can leave in the link above. So here I have a situation where I have a square root function instead of polynomial on the top and polynomial in the bottom. And also, I cannot do the direct substitution, because if I try to directly plug 0 in the top, I will get 0 and I will 0 in the denominator. So I can see that x square is making a 0 in the denominator. So in order to get rid of x square, I need some sort of x square in the top also. So how I can do it, basically, how can I get rid of this square root of function? So whenever you see a square root of function, you need to use this technique, which is called a rationalization, rationalizing the top and bottom. So how to rationalize? If you have a number a plus b, you need to find its conjugate. The conjugate is simply whatever is the middle sign, you switch that sign. If it is a positive, switch to negative. If it's a negative, you switch to positive. So you have a plus b, its conjugate is a minus b. And they have an interesting property. When you multiply by a number, its conjugate, the number is a square minus b square. After foiling out, you only left the square of the first minus the square of the second function. So if I do the same thing, if I multiply its conjugate, which is a x square plus 4 and then plus 2, because there was a negative sign, I changed to positive sign, and I multiply in the denominator as well. Now let's try to simplify the top and bottom. Since in the top a number is multiplied, it is conjugate, so this number is multiplied its conjugate. So this is going to be a square minus b square. What is the first term? The square of the first term, x square plus 4, the square of that, minus the square of the second term. And the denominator term will not change, x square, square root of x square plus 4 and plus 2. Next step of simplification is the square root and square, they cancel to each other. So you have just x square plus 4 minus 4. And then you have x square x square plus 4 plus 2. And then that 4 cancel out, so this get you limit x approaches to 0, x square divide by x square, which is x square plus 4 plus 2. As you can see that since we have the 0 over 0 form and that x square was making the 0 in the denominator, you see that there is a x square in the top also, which is cancel out that x square, and you don't have any more 0 over 0 form. If you plug x is equal to 0, you will get 1 over 4 as your answer of the limit. So yeah, this is basically whenever you have a 0 over 0 form, it means there was some x square which was making in the 0 in the denominator was hidden in the top. So you just have to get it out. And when you have the square root of functions, in order to make the polynomial in the top, or in order to get rid of the square root from the top, you have to multiply its conjugate. Here I have a bit different situation where we don't have a polynomial in the top. Instead, we have a rational function. So again, if you try to do the direct substitutions, you will get a 0 over 0 form. And you can see x minus 3 is making a 0. So there must be x minus 3 hidden in the numerator, which we have to find out. So when we have a quotient function, so how to simplify a quotient function is you use the same denominator technique. So you try to make the same denominator and then try to add or subtract these rational function. So this is how we will begin. Limit x approaches to 3. We have 1 over x square minus 1 over 9 divide by x minus 3. In order to do the same denominator, I will multiply this by 9. So I multiply the 9 in the top also. I multiply x square. I have to multiply the x square in the top as well. So after the simplification, after making the same denominator, I can add the top, which is add or subtract 9 minus x square. And this is a 9x square, which is a common denominator. Since this is a divide by x minus 3, I can multiply by 1 over x minus 3. Now I have a polynomial in the top and polynomial in the bottom. I can factor. Limit x approaches to 3. If I factor, I can get 3 plus x and 3 minus x on the top. The bottom is x minus 3. We are almost there. So you see x minus 3 is a problematic factor in the denominator, which we would like to cancel. But here is a 3 minus x, not x minus 3 exactly. So in order to make x minus 3, I will pull out the negative sign from that factor and it will become x minus 3. And now we have 9x square x minus 3. So this factor will cancel out. And after the cancellation of this factor, we should be able to calculate the limit by just directly substituting. If I just directly substitute x is equal to 3, I will get 6 in the top. I will get negative 6 in the top. And in the bottom, I will get 81. So this is my final